Okay, this is the experimental design video. This is just chapter 4. We tend to think that this is our worst chapter. So these are the 5 questions that's going to be going over on the test from Tuesday. The biggest thing I've said over and over and over again, if this has consistently been your lowest, it was your lowest on the mock, it was lowest on this test still, you just got to sit down and make some flashcards and study, or you've got to read the book. Like, at a certain point, it is just memorization of what is simple random versus cluster versus stratified versus all the experiments. Like, you just have to memorize the vocab. There's still some details that get tricky with this chapter, but when it comes to just what are the different vocabulary terms, you've got to memorize. So read the chapter, make flashcards, do whatever you got to do. Find something on Quizlet and study there. I don't care. Here's a quick rundown of what chapter 4 was all about. I've already kind of hyped it up. I just erased some of this. Types of sampling, and that also includes good sampling versus bad sampling methods, the idea of bias, and then we got into experimental designs and all the different ways you can randomize, PAT method, using the random digit table, that kind of stuff. And this is also where we first introduced the idea of statistically significant, which we've done a lot more now since we've been doing inference, but this is where we first introduced the idea with dot plots and all that. Okay, so let's look at number 2 from your test. Get a little closer. Okay, so since this is mostly vocab, I'm going to try to show you guys the wording within each question that helps me decide what the answer is. So on this one, a school principal wanted to investigate student opinion about the food served in the school cafeteria. The principal selected, and then here's the important part, that's bad wording, random samples of, and then it goes on to list 50 first-year students, 50 second-year students, and so on. But the fact that we are doing random samples from multiple categories, multiple sections, groups of people, immediately means it's a sample. So if there was any kind of experimental design, like completely randomized or blocked, you could get rid of those choices. And if you're doing multiple samples, it immediately has to be a stratified. Make sure it's clear, it's A. Okay. Again, if you know your vocab, that should be pretty obvious. But look for that key wording of multiple samples happening. All right, then we have number 8. This is talking about right away an experiment we're conducting to see if they learn multiplication facts better by practicing with flashcards or with a computer. Children volunteer, so it's definitely not a sample. It's just an experiment. They're randomly assigned one of the 2 treatments. But do you see how, it says gender may affect the outcome, so they're blocking by gender. So that just means they'll take all the girls and randomly split the girls up into flashcards versus computer, and then take all the boys and randomly separate them as well. After practice, the children will be given a test on the multiplication facts. So it's got the 4 concepts of experimenting. It's got comparison, flashcards versus computer. It's got randomization with the blocking method. It didn't get into detail, but randomly assigned. Control. We didn't go into detail, but we assume they get the same flashcards or the same computer program. They're taking the same test afterwards. They probably get the same amount of time to study. Why is it impossible to conduct a double blind? So again, vocab. Double blind just means that the experimenter does not know which treatment each individual received. That's not that hard, right? The person who gives the test afterwards, they don't know, they don't have to know if the child taking the test in front of them used flashcards or computer. So it's okay this would be doable for the experimenter to not know. But double blind means that the experimenter, the person running the experiment, and the subjects can't know what they received. And the subjects, the children in this case, definitely know if they studied flashcards or if they studied from a computer program. So the reason it's impossible is that the child will know whether he or she used flashcards or the computer. Okay, again, I'm hoping logically some of these you can get rid of, but that is why this cannot be double blind. All right, next one. We got number 14. Okay, I'm going to skip down just so I know what I'm looking for. The result was statistically significant. Which of the following can be concluded from this study? So we're talking about conclusions. Okay, so a recent study examined 699 car accidents over a 14-month period. Records of phone service providers were used to determine whether the driver was using a cell phone during or immediately before the accident. Overall, the researchers found that drivers using cell phones were 4.3 times as likely to have an accident. Okay, so we're talking about conclusions that can be made. When it comes to experiments versus studies, we had our scope of inference, and there's two different things you can decide. Does your information apply to a larger population? Did you do good sampling to get this data? In this case, it doesn't really specify. They just examined 699 car accidents, so they did not randomly sample amongst car accident records or anything like that. The other option is that if you do an experiment where you actually take the subjects and randomly assign them to treatments and then do all the controls and everything, you can get a cause and effect relationship. Now, it would not be ethical to put a bunch of people in cars and say, you have to drive with texting, you have don't. So this is definitely not an experiment. This is just, and it even says study, an observational study. They're just observing things that already happened. So immediately you can say there is no idea of any kind of causation. There might be correlation, there might be some sort of positive relationship, but there is not an actual cause and effect link that has been proven. So anything that has anything to do with that kind of wording, you might not use the word cause, but anything that mentions that kind of idea we can get rid of. So A, cell phone use increases the likelihood of a car accident. That's kind of, again, sort of in that realm. I could see maybe skipping that one if you're not sure to get rid of it or not. There's an association between cell phone use and accidents, but not necessarily a causal relationship. That is actually a pretty good answer. I would not get rid of that right away. C, there is a correlation between cell phone use and accidents, but not necessarily an association. Association and correlation are really kind of two of the same thing. All right, association is just saying relationship. Correlation, relationship. You could still calculate a correlation even if it was a quadratic data. So that's not really a good answer because that doesn't make sense. D, the association between cell phone use and accidents is negative. Well, that's just not true. They even said earlier that phone usage makes accidents increase. So it would be, if anything, positive. So again, that's just a not true statement. E, cell phone use causes. Get that out of there right away. I didn't even finish reading it. Cause out. Okay, of the two that were left, A was kind of, to me, implying a causation. It's not as explicit as E, but to me it kind of makes it sound like it's saying it's a cause, whereas B is purely just saying there is a relationship, which is true. Okay, so there you get that. Number 16, why is stratification used? You'll notice that I tend to do this a lot, especially on word problems. Skip to the end, see what the question's asking. Okay, it's talking about stratification, so now I can kind of wrap my brain around, okay, what do I know about stratification? And then go back and read the problem with that kind of scope on top of this. But it's asking about why specifically. Okay, so they're interested in estimating the mean number of minutes working adults in the region spend commuting. They did a random sample of working adults. There's 3 strata: urban, suburban, and rural people. Selected individuals and asked the number of minutes they spend commuting to work on a typical day. Okay, so why do we stratify? Typically, it's to reduce variation, which is our favorite kind of word to just throw out there, but don't go into specifics. So we want to reduce variation, but in what? This would be a great example of where I would put of what on your free response. It is always in our response variable that we're trying to get as narrow of a range of numbers as we can. So in this case, the response that's being recorded is the mean number of minutes working adults in the region spend commuting. That is the response. So the whole goal of stratifying is to make that number, the mean number of minutes working that the commuting people take to get to work, is as small as possible, right? Or as less varied as possible. So keeping that in mind, let's read through the choices. A, B, and C all say something about removing bias or reducing bias. Bias, by definition, is either a flaw in your sampling method or something that you cannot control. People lying on their survey, people forgetting details. certain people not being reached by whatever method you chose to do your random sampling. That cannot be fixed by stratifying. So we immediately are going to get rid of all that stuff. Bias is a flaw in the design, typically. Not able to get rid of that or fix it by doing something else. Okay, so then here we go. Reduce variation, decrease the variability in. So we're talking about response. Response was that mean number or the amount of commuting time. So if we look at the two choices, that would make it E. Okay, so takeaway here. Stop saying reduce variation. Stop. Just give me that. Be more specific. The response. And then remember always context. I just wrote in response, but remember the context. Always, always, always. All right, last but not least, 17. A randomized block design. So I want to make sure we understand this is talking about an experiment. Okay, randomized block. It's like the idea we just talked about with stratified, but this is an experiment. Will be used in experiment to compare two lotions that protect people from getting sunburned. Which of the following should guide the formation of the block? So remember, the idea is we want to reduce the variation in the response. We want to reduce variation. Now, in this case, the response is the explanatory is which lotion did they get? Did they get the lotion A or lotion B? And it's trying to help protect people from sunburn. So it'll reduce variation in, I guess, sun damage would be what they would be measuring somehow. So which of the following should guide the formation of the blocks? So that's our goal, is to reduce the variation in sun damage. So whatever you're doing with the blocks should help with that. The other idea with block is that each block has similar people in it. So each block has similar people, and then you would take that block and split it up against the two lotions. So participants in the same block should receive the same lotion. That is not how blocking works. Remember, each block has similar people, and then you split them up. So you would split this up into lotion A and lotion B. Participants should be randomly assigned to the blocks. No, the whole point is that you're blocking them by some sort of characteristic they have in common. Participants should be kept blind as to which block they're in. Maybe, but that might not be the biggest issue. I'm not necessarily going to get rid of it because it's not necessarily the worst thing, but maybe it doesn't answer the question. D, participants within each block should be as similar as possible, with respect to how easily they get sunburned. Remember, that was the response. So definitely better than C. I'm going to get rid of that now. And then E, the only difference is it says similar versus different, so definitely D. All right, that's it. So go grab your practice sheet. I believe it's yellow.